Hey everyone, thank you for joining us today to the Wormhole workshop at Injective Hackathon. Today we will show you how to build cross-chain dApps with Wormhole and Injective.
Thanks, Vivian. So thanks to everyone for joining. Hope you can see my screen. My name is Nikhil Suri. I'm a contributor at Wormhole. And today I'm going to be running a quick workshop on what is Wormhole and how to build cross-chain dApps on Wormhole. So let's get started. So what is Wormhole? Wormhole is a generic cross-chain messaging protocol. But that is like the tagline. What does that really mean? What that means is it allows you to pass data from one blockchain to another blockchain in a standardized and secure way, so you can easily take your app cross-chain. Um, and Wormhole supports 22 different blockchains. And one of the hard problems that Wormhole solves is that it supports both EVM and non-EVM chains. So Wormhole supports Solana, Cosmos, Algorand, Moonbeam, Near is up there as well. All of these ecosystems are connected through Wormhole. So why are we all here? We want to build stuff and grow our projects. So what can you build with Wormhole and how can it help you grow your project? So there are several reasons why Wormhole can be helpful to you as you build and grow your projects. The first one is it enables you to expand your user base. So with all the chains that Wormhole supports, you can tap into an incredibly significant number of crypto users. Um, and then second, once you have those users, you can greatly expand their reach. So now they get to stay on the chains that they're comfortable with. They get to keep using the wallets and the UIs that they're familiar with. And they get to do all of this while staying in their comfort zone, and they can interact with any of these chains that Wormhole supports. And then finally, you and your team can focus on building where you have the most expertise. Um, Building product in crypto is very difficult, as you are all well aware. Different chains use different languages, they have different VMs, they have different consensus mechanisms and finality guarantees. And then, possibly most important of all, as we've seen over the last year in crypto, is security. The security assumptions built into each chain's VM and consensus mechanisms can be very, very different. Um, excuse me. So if you have a team with expertise in every single one of these ecosystems, then that is awesome. And you've just solved one of the biggest barriers to building in crypto. If you don't, then you're like all the rest of us. It's really challenging to go cross-chain. And so this is one of the biggest things that Wormhole unlocks for you, which is that you can keep building where you want to build, and you can seamlessly bring users into your ecosystem of choice. So we've talked a lot about building. What can you actually build with Wormhole? And for this, there's no better inspiration than some of our favorite projects that are out there. So first, we should talk about the more sort of protocols that exist on top of the Wormhole generic messaging layer. So there's the token bridge, which is probably the most famous or well-known use case of Wormhole. And then there's the NFT bridge. And so as you might imagine, the token bridge lets you send tokens from one chain to another chain. And the NFT bridge lets you send NFTs from one chain to another chain. Um, and the way to think about how these work is that, for example, the token bridge contract will mint a wormhole wrapped version of the token or NFT on the destination chain. And then what a lot of projects end up doing is they treat this wormhole wrapped version as the canonical version of their token on that chain. Um, and so, for example, if you're going from ETH to Polygon and you want to wrap or we want to bridge native Ethereum, what's going to get minted on Polygon is wormhole wrapped Ethereum. That's this example right here. Um, but remember, Wormhole is a generic messaging protocol, so you can do a lot more than just bridging tokens and NFTs. So beyond those, there are a bunch of products that are built on top of Wormhole, and here are some of our favorites. So one is Carrier by the Automata team. They've built a beautiful token bridge and NFT bridging UI. Um, then there's Pith, which is a market data oracle, and it leverages Wormhole generic messaging to publish prices to different blockchains. And then there are Hashflow and Backpack. So Hashflow is a cross-chain swap. It's RFQ based and it uses Wormhole generic messaging to facilitate cross-chain swaps. And then Backpack is a cross-chain wallet that'll be launching soon. And then another cool one is called Nexa, and they're doing cross-chain token mints or X mints, as they call it. And so again, if you think about all these different projects and how they're using Wormhole, they're using those strengths of Wormhole that we talked about earlier to, one, expand their user base, two, expand the reach of their users, and then three, focus on building where they have expertise or helping other projects like you focus on building where you have the most expertise. So with all this high level stuff aside, we're at a hackathon. We want to know, how does Wormhole work and how exactly do we integrate with Wormhole? So we'll go over some diagrams and then we'll dive into some code. And so I have some links up here right now of code and documentation. You can pull these up as I talk through, have them on the side. We'll also walk through some of these later on. So first is the Wormhole docs. That's at book.wormhole.com, home for all Wormhole documentation. And then we have some important GitHub repositories. The first is the Wormhole mono repo. That's where all the code for Wormhole, all the contracts on different chains, the entire implementation is. And there's also some documentation, some white papers in that repository as well. And then two examples that are example applications, cross-chain applications, reference implementations that are built on top of Wormhole. One is cross-chain deposits, and one is an example of a cross-chain borrow-lend protocol. So going into a quick overview of how Wormhole works technically. So we have contracts deployed on every single network that we support, EVM, Solana, etc. And these core bridge contracts take care of three key things: publishing messages, which then get bridged to another chain, verifying messages that are coming from another chain, and then the third is executing governance actions. So that's what this diagram here on the right shows. There are the core bridge contracts on every single chain, so ETH, Solana, and all the other chains, and they handle publishing and verifying messages. And these messages pass through the Wormhole core layer to go from one chain to the other. But what is actually in this core layer and how these messages move around and what makes sure that the messages are valid? So that is where the Wormhole guardians come in. So they fill up what's in this core layer. There are 19 Wormhole guardians, and what they do is they run full nodes to observe messages that are emitted on source chains. Then they wait for the messages to reach a certain consistency level. So for ETH, for example, they'll wait for the message that was emitted on ETH to reach finality. And then once a Wormhole message that they've observed has reached finality, they'll sign that message. And then when 13 guardians have signed a message, we call that a VAA, which stands for Verified Action Approval. And then this VAA exists in the Guardian database, and each Guardian has exposed RPC endpoints that you can query against to get your VAA. And then you can submit this VAA to the Wormhole contract on the destination chain, which will verify the signature and allow you to perform whatever action you need to perform. So the Guardians take care of these four key steps. And a lot of info right there. And so the next slide I'm going to show you details the entire Wormhole message lifecycle, so it gives you another view into what we just talked about. So this is the entire Wormhole message flow, how a message gets from a source chain to a destination chain in 8 steps. So first, you start on the source chain, and the integrating contract or program. This can be actual contract that you write that composes on top of the Wormhole contract, or it can just be a basic JavaScript program. Um, Whatever program you write calls into the Wormhole core bridge contract on that source chain, and then the Wormhole core bridge contract just emits a Wormhole message containing whatever payload that you wanted to include in that Wormhole message. And let's say this source chain is Ethereum. Then the off-chain process kicks in. So the guardians are running full nodes for every chain that Wormhole is connected to. And the guardians will be running a full node for Ethereum. They will observe this Wormhole message that has been emitted as a log on Ethereum. They will wait for it to reach finality, and then they will sign it. They'll verify it's valid, and then they'll sign it. And then once 13 of the 19 guardians have observed the message and signed it, that produces what's called a VAA, the Verified Action Approval. And then this VAA exists in the Guardian database. And an off-chain process, untrusted off-chain process called a relayer. This can be run by you, this can be run by anyone, picks up that VAA and then submits it to wherever it needs to go. So it'll submit it to wherever it needs to go on the destination chain, whatever contract is building on top of Wormhole. That destination chain will verify the VAA by calling the Wormhole core bridge contract on the destination chain. The Wormhole core bridge contract will say whether or not the VAA is valid, and then return to the integrating contract, which can take some whatever arbitrary action it needs to take with that message. So this is the whole message flow in Wormhole. And how do you, as the developer, plug into this entire thing? So two things. First, you write the program that calls the Wormhole contract on the source chain. Again, it can be a contract you write if you want to compose on top of the Wormhole contract, or it can just be some simple JavaScript. That calls into this Wormhole core bridge contract. So you write this program here, and then you write the contract on the destination chain that composes on top of the Wormhole core bridge contract. So you write the contract that will receive the VAA, verify the VAA against the core bridge contract, and then take whatever action needs to be taken based off of the content that's in that VAA. And then in some cases, you also need to write or maintain your own relayer, which is a very lightweight process that will pick up the VAs and deliver them to the contract, to your contract that you've written on the destination chain. That requirement is soon going to be gone on EVM chains with the introduction of what we call generic relayers, but that's still under development. So right now you would need to maintain your own relayer that's going to pick up the VAs and also deliver them to where they need to go. So this is the entire message flow and how you, as the developer, can plug into this message flow to go cross-chain. So now let's dive into the code. So let's talk about we'll talk about the Wormhole repository, how to navigate it, and how to integrate with some of the functions on the Wormhole contracts, and then we'll talk about the examples, the cross-chain deposits and cross-chain borrow lend examples, which show how you can integrate, which are example projects or reference implementations of protocols that integrate with Wormhole. So for the Wormhole repo, that's here. And I'll share my screen and do some navigation of the Wormhole repository as well. But basically, there are useful documentation in the, let me actually exit here and show you. So in the Wormhole repository, this is the Wormhole book. First off, this is our home for documentation. The Wormhole repository is here. This is the monorepo, contains all the contracts and the Guardian implementation, relayer example implementations, white papers. So there's some useful docs in the white papers folder. These have documentation on all things generic messaging, how generic messages are passed, token bridge, NFT bridge, and various other features. There are contracts that are deployed to each chain in the folders named after each chain. So Algorand contracts are here, Aptos is here, CosmWasm contracts, that's probably most relevant for you all, since this is an Injective hackathon, are here. Ethereum contracts are here, Solana contracts are here, etc. The Guardian implementation is in the node folder. If you're curious, you can look into that. You probably don't need to if you just want to integrate on top of Wormhole. We have a JavaScript SDK in the SDK folder. This is again, if you want to easily, be able to call a Wormhole contract from just JavaScript code, you can use this SDK. And then there are some sample relayer implementations. For example, in the SPI relayer, and if you explore the Wormhole Foundation organization, there are newer relayer implementations. There's Relayer Engine, which is a pretty useful relayer implementation. So if we want to look at how, for example, the core bridge contract works, we'll dive into the CosmWasm folder. We'll look at the contracts. And so there are a bunch of different CosmWasm contracts that we have. Wormhole contract is the core bridge contract. Dive into the source code here. And if we look at the execute function here, so these are the functions that you can call, that you can execute on the against the CosmWasm contract. As an integrator, if you want to send a Wormhole message, you call this post message. You will execute a post message, and that you pass in some payload. And then all this really does, if we look at the implementation, is it just logs a message. And that's exactly what we talked about. All that happens when you want to send a Wormhole message is you call into the core bridge contract, it'll emit the message. The Guardians will be listening for that message. And then the other main thing is verifying the VA. So if you want to verify VA, so if you're composing on top of the CosmWasm contract and receiving VAAs and want to verify them, you would call into this query endpoint here, which is query message verify VAA. And this calls into query parse and verify VAA. And if, as you see here, all that's happened, this calls into another internal function, but all that's happening here is we check if the VA has already been submitted. We check the Guardian signatures on the VA. And yeah, we do some signature verification here. And then if the signature verification passes, then everything's okay. If it doesn't, then we return an error. So verifying a VAA is a query endpoint, and sending a message is an execution endpoint. So that's the core bridge. Then there's also the token bridge. So many of you may want to build something on top of the token bridge. So for an example of how the token bridge composes on top of the core bridge, so it's in the contract is token bridge, contract.rs is the source code. So here's the execute function, and here we can see the code for initiating a transfer. So if you want to like bridge a token, you can see how we compose on top of the core bridge. Um, handle initiate transfer, handle initiate transfer token. And what we do is we will basically call into the core bridge contract post message, just as we saw before. There's a bunch of other code here, which we won't get into, but this is kind of the core integration point here of how the token bridge integrates with the core bridge. And a useful example, if you want to roll your own sort of generic messaging protocol on top of Wormhole. So if you want to bridge messages back and forth, and do that on a Cosmos chain or do that on Injective or send from a different Cosmos chain to Injective, this is how you'll do it. And then if you want to like complete a transfer on the token bridge, so let's say you want to receive tokens to Injective and then compose on top of the token bridge on Injective, for example, that's in complete transfer. So complete transfer is the function that you'll call to receive a token bridge, to receive a token bridge VAA to bridge tokens. And you can dig into the code here to see how this composes on top of the core bridge to, you know, verify the VAA. So yeah, that's the token bridge and the core bridge. Let's go back to the presentation. So that's so what we just talked about is like what I call level one composability, which is building your own messaging protocol and messaging format sort of directly on top of the generic messaging layer. So that's like building the token bridge directly on top of the Wormhole generic messaging layer, or the NFT bridge directly on top of the generic messaging layer, or like Pith is another example of a project that builds directly on top of generic messaging. But you can also do what I call like level two composability, which is you build on top of these level one protocols. So you can build on top of the token bridge, you can build on top of the NFT bridge, you can build on top of Pith. And so one common use case is you want to use the token bridge to move assets cross-chain. And so this is where those examples that I mentioned before, the cross-chain deposits and the cross-chain borrow lend reference implementations come into play. So we can walk through those right now. So what is a cross-chain deposit? It's a very common use case where you have a source chain and a token on that chain, and you want to change that into a different token on a different chain. So for example, if you want to go from ApeCoin on Ethereum to USDC on Polygon, probably one that's more relevant for this hackathon is like ApeCoin on Ethereum or any token on Ethereum to any token on Injective, USDC on Injective, or some other token on Injective. And so you don't just want to necessarily swap these tokens or do a cross-chain swap. You want to use that cross-chain transfer to enable some sort of other functionality. So for example, you want to perform a payment where the user pays on the chain they're on, and in the background, it gets converted into whatever you want to receive. So again, plays into the principles we talked about earlier, expanding your user base, expand the reach of your users, and you enable everyone to stay within the ecosystem they're comfortable in. So we can go through this super simple example that I put up on GitHub of how you might build this, which is this chain deposit repo. This is an example for reference. I hacked it together really quickly. the contracts haven't even been deployed, but it demonstrates how to build on top of the token bridge. And also, this example is in Solidity. Something cool that you all could do for a hackathon project is you can build a CosmWasm version of a cross-chain deposits. So basically, the way that cross-chain deposits work is you can look at this diagram here. The function or the contract, the cross-chain deposit function, will call into the Wormhole token bridge to complete transfer with a custom payload. The token bridge verifies the VAA. The core bridge says the VAA is valid or not. So this is the standard integration of token bridge and core bridge. And then the token bridge will basically return wormhole wrapped from our example. If we want to bridge ApeCoin, it will return wormhole wrapped ApeCoin to your contract, and then your contract can sort of take a further action on top of that wormhole wrapped coin that was just minted to it. So for the cross-chain deposits example, if you were to follow this link here to the GitHub repository I put together, this is the function that will receive the VAA and then call into the token bridge complete transfer with payload. So again, this is Solidity. So not sure how familiar you are with how this works, but it's translatable over to CosmWasm as well. So this function receives a VAA, calls into the token bridge to verify the VAA, and then the token bridge, once the VAA has been verified, will return a payload of a custom message that we sent from the source chain, and then we can parse that custom message and take further action on it. And so this is like the custom payload that you can send. So this is like the standard token bridge payload. This payload ID, amount, token address, token chain, to chain from address. These are all standard token bridge fields that you need to populate to do a token bridge transfer. And then this is kind of an arbitrary payload that you can add on to the end that instructs any kind of arbitrary action you want to take after you receive wormhole wrap tokens. And so, for example, for the cross-chain deposits example that I put together, my custom payload would be this arbitrary payload would be decoded into this, which is a recipient address and target token. So I would receive the wormhole wrapped tokens, swap to the target token, and then send to the recipient address. Yeah, and this just shows how you can decode that payload into the custom payload. So that just takes this bytes payload and decodes it into this custom payload that I have here. But you can dig into the code to look into how exactly this works yourself. And so that's for cross-chain deposits. Another cool example is a cross-chain, borrow-lend protocol. So here's another GitHub repository with a reference implementation that one of my teammates put together of how you could build a cross-chain borrow lending protocol using Wormhole. And this is, again, implemented in Solidity for EVM. And a really cool thing that you could do for this hackathon is port this over to Cosmos. You can port the contracts for the borrow lend to CosmWasm. And so this borrow lend example follows a hub and spoke model where users on spoke chains perform actions that are communicated to the hub chain. So from a spoke chain, let's say the hub chain is Injective, and then the spoke chains are Ethereum, other Cosmos chains, Polygon, from the spoke chains, you can deposit, you can withdraw, you can borrow, you can repay. And on the hub chain is where assets will actually be sort of stored. So these are some of the core touch points to look at if you want to build a borrow lend protocol. This is kind of where the core logic is. So this is the function that is on the hub chain, would receive the VAA and then take whatever action the VAA says, like whether the action is deposit, withdraw, borrow, repay. This receives the VAA, verifies the VAA against the token bridge, and then sort of like performs that action on top of it. And then this is showing where on the hub chain contract, we actually call into the core bridge to verify the VAA, and then where we sort of decode our custom payload and call into the token bridge. So again, if you were to port this to CosmWasm, these are sort of key functions that you want to understand and then port over to Rust. Yes, so those are the examples. Again, the GitHub repos, in case you didn't catch before, are here, Wormhole Foundation, example Wormhole lending, and here under my GitHub, Nik-Suri, X-chain deposit for cross-chain deposits. And for the hackathon, we're offering a Wormhole bounty, which is a 5K discretionary prize, and it's for building on top of Wormhole. And some really cool ideas that you can implement are cross-chain primitives like cross-chain borrow lend, and you can use the example Wormhole lending repository if you're building a cross-chain borrow lend protocol, cross-chain payments or cross-chain deposits. And you can, for cross-chain payments or cross-chain deposits, you can use the X-chain deposit repo that's on GitHub as well for reference as you write contracts in CosmWasm or Rust. And then some cool things that are coming next. There's Wormhole Connect, which is like a widget that you can embed onto your website. That'll give you a quick UI. That'll make it really easy for people to bridge assets back and forth and make use of projects that have been built on top of Wormhole. There's generic relayers that I mentioned before. Generic relayers will make it so that you no longer have to run your own relayer to pick up VAs and submit them where they need to go. Generic relayers mean that all the work will just happen for you in the background, and you just can focus on writing a program on the source chain and the destination chain. There's Worm Router, which is going to make integrations easier. There's Wormchain, which adds a bunch of security features. For Cosmos, it's pretty exciting because it'll be adding a gateway into IBC, and it also will add cool features like cross-chain queries and cross-chain hooks. And then ZK bridging as well. Trustless bridging is something that is on the horizon that we're all working on. So yeah, that's all I had. Thanks so much for listening. Look forward to seeing what you all build for the hackathon. Yeah, you can reach me. My Twitter is nsuri_. My Telegram is just my first and last name. And I'm going to be in the Discord. So feel free to drop any questions and I'll try my best to answer them.
Thank you so much for this amazing presentation. And I think our hackers will know where to start and how to